In the last video, we looked at the basic definition and principles of the model view controller design pattern. And we also took a little bit of a closer look at where different parts of code in a Java GUI app would fit inside of the model view controller design. In this video, we're going to take a closer look at the benefits of using the model view controller design pattern. So now that we've seen the basic layout and some examples of where the different parts of a game go, let's talk a bit about the benefits of using a model view controller design. So the key part here is it makes your code easier to understand, right? This design is convention for where you put different pieces. The GUI pieces go over here, your application logic goes over here. So by following the convention, you know where to look for a particular piece of code. And so if you're a new person joining a project, a new employee to a company, you get this new body of code you've never seen before, you have at least some idea of where to start looking for things. I'll draw an analogy to if you've ever looked under the hood of a car, right? Fords and Chryslers and Jeeps and all these different cars, what's under the hood is different on each one, but there are some conventions. So although what's under the hood of your Ford and your Chevy doesn't look identical, at least when you open the hood, you have some idea of what you're looking at or where the thing you're looking for is. You're not starting completely from scratch every time you open the hood of a new vehicle. Likewise, when we use this model view control pattern across a wide variety of applications, when you first look under the hood of your code, you're not completely lost. Likewise, when you go to start a new project, you don't have to reinvent the wheel. You don't have to stop and make every last decision from scratch. There's a number of decisions that are standard and are ready to go. What code goes in the view, what code goes in the model, and you don't have to spend time rethinking that every time. And this pays off in the long run because if the code's easier to understand, it's also easier to maintain when you need to add features or fix bugs or whatnot. Now, the other thing you get from a model view controller design is that your code is what we call loosely coupled. That means that the code in the view is not highly dependent on what's going on in the model and vice versa, which means changes in one module are less likely to affect changes in another. If you're changing your view and your code is designed with what we call loose coupling in mind, then you're not likely to screw up the model, or vice versa. If you're making some change to the game rules, where you're adding a new variant to the game and what have you, the looser that coupling is between the model and the view, the less likely you are to goof up your view by changing your model. Now, I say less likely, you're not completely isolated from this, but loose coupling is a general principle of good software engineering design. So along that lines, what you get from MVC is separating that UI from the application logic. So in addition to just the general benefits of loose coupling, it makes it easier to change the look and feel of your application without having to dig into the model. And there's a couple of ways that looks. One are just simple updates, making something look fresh when the marketing team gets bored. It also means you can more easily do things like have a graphical user interface and a text interface. The more separation there is between the model and the view, the more you can focus on having those multiple interfaces. In the world of web design, that can also mean it makes it easier to have the same back end working with an Android or an iOS app. And then the last thing I'll mention is it makes it easier to unit test. The particular division of model view controller plays well into testing. Let me expand on that a little bit. With the view, the user interface is generally difficult to unit test. It's not really clear what you're looking for because the view isn't about states and stuff. At the end of the day, the question is, does the view look good on the screen? Can you see everything? Is it in a logical place? Can you interact with the buttons and the sliders and everything? And that's not something that is readily testable like in a JUnit sense. There are some packages that head in that direction, but most companies still need a human to actively interact with an application to make sure that the view works the way you want. It's very hard to completely automate the testing of the user interface. So by using a model view controller design, you put all of that almost impossible to test code, all of that code that can really only be checked off by a human, all in one spot, all in one module. The model is where most of the code that at least I think of as heavily testable goes. That's where the interesting logic is, that's where the edge cases are, that's where the clever algorithms are. They tend to be in the model, inside of that application logic, and also the code that makes sure that you're keeping track of the state correctly and you're not forgetting stuff, so to speak, or letting stuff get overwritten. And in some sense, this is where the important logic of your application goes, whether it's the game rules or just the logic that makes your application, like in the world of web, something unique and different, your algorithm or whatever your niche is. So by isolating all of that in the model, you can focus on those key aspects of your application without having to think about the view or the controller. Now, the controller tends to have some unit tests. Like I mentioned, you don't want any of your business logic in your controller, but sometimes there's a little bit of logic. There might be an if statement determining which model method you call. So you might want some unit tests. They tend not to be focused on logic as much as they are just making sure the right methods have been called. And we're not going to get into that in this class too much, but the technique you use is called mocking, where you run the test on the controller, and as you run the test on the controller, you watch what methods it's calling, but you don't actually run those methods. So I don't want to get too much into that. I'm happy to talk about mocking offline. But I will say the part of the controller that plays nicely into testing is most of the stuff that you would want to mock ends up in the controller. Although if your model is using like web services and stuff, those might also get mocked out as well. But again, it's another example of how this design separates code not only according to what it's doing, but also according to the way you'll tend to test it. All right, so let me wrap up with a few reminders or a little summary here. So remember, the view is where all of your user interface code goes. And so in the world of a Java application, pretty much anything that comes out of the JavaX Swing package or the Java AWT package should go in your view class. So if you're new to this, there's your warning sign. If you find yourself saying import Java Swing or import java.awt inside of your controller or model, you're probably doing something a little bit wrong. Don't want to say never, but if you think you need to do that, then you might want to check with your instructor and see if there's a better way to do it. Remember, the view should not contain any application logic. If you're writing a game, none of the rules of the game should appear in the view. The view should not directly modify the model. So for example, when you click the roll button, it shouldn't be the view telling the model to roll the dice. The view shouldn't look at the score and say, oh, the score is wrong, and call a method on the model to fix that. Right? The view should only be drawing a picture. The model is where all the application logic goes. So if you're building a game, remember, anything to decide if something is within the rules or any source of data that keeps track of the state of the game, whose turn it is, what the score is, what moves are legal, that should all be in the model. And then the controller is what ties it together. And in the world of Java, that's where your UI listeners go. And yes, I know that will feel a little weird the first time you do that. We'll have to talk about that in a different lecture. And remember, just like the view, the controller shouldn't have any state or application logic. That should all get pushed down into the model. So hopefully that gives you a good starting place for working through your first model view controller application, and you have some appreciation of why we do things this way. It's certainly not the only way to do it, but As far as I know, it's the most popular anything I've ever done in the business world in terms of a user interface application has had some form of model view controller design. So try it out on an application of your own and let me know if you have any questions.